Right, well, thank you very much for having me in tonight. Tonight's talk is very excitingly called Artificial Intelligence and the Future of Business. I think at the moment in the world of tech, under the assumption we're all interested in tech, there's a lot of really exciting things going on. Artificial intelligence being one of them, but obviously we have a whole host of other technologies, things like augmented reality, virtual reality, we have IoT and connected devices. And in a lot of ways, all of those coming together and using AI is one of the most exciting things at the moment. There's a bit of a disclaimer at this point. AI is a massive, massive subject, as I'm sure we're all aware. We could talk for hours about it over a whole host of different things. So we're really going to talk about a relatively small part of it today. And then obviously if you want to ask any other questions, then come and find us afterwards. So this is me. I'm the founder and the MD of Sonin App Development. The clue's in the name, so we are app developers. What we do is kind of split between the consumer side of stuff that we all download and use from the App Store every day, and then the enterprise side, which are internal use apps, and they're typically kind of streamlining of efficiencies, that type of thing. My personal background, I used to be a developer, so back in the day I used to do things like write business continuity software for Royal Bank of Scotland. There's also risk management software, which was a much better claim to fame before they failed to manage their risk completely. Since then, I've been kicked out of the development side by the team, and I now spend most of my days talking to businesses about what it is they want to do and how it is we can use technology to help them do that. So we have a few of the team here today. This is a subsection of them, so some of them you'll see up here. Feel free to grab them afterwards and ask them any questions. As you can see, we seem to have a strict blue and white policy for the work outfit. But there's a few of the guys bounced around here, a couple of the developers, and also if you have any specific questions from a really technical side of things about which platforms to use, whether you should be using TensorFlow or H2O, for anybody that's kind of at that level, I strongly suggest that you catch James here, black jumper, sat at the front. Afterwards, grab him and grill him because he'll be able to answer you any questions about which is the best platform to use. Right. So anyone that's ever met me before and has spoken to me for more than about 30 seconds will undoubtedly know that I have 2 children. It's about the first thing I'll ever talk about. I have Josh, who's about 2.5 years old, and I now have Ollie, who is all of about 6 weeks old. A few years back, my day used to start about 5:45 with some crying, at which point I'd fumble around in the dark and I'd try and find my phone or the alarm clock. I'd roll over and I'd look at the time and I'd think, right, this is it. There's no way he's going back to sleep. It's time to get up. I'd stumble across in the dark. I'd hit the light switch. I'd wake up uncomfortably. We'd go downstairs. I'd turn on the TV and I'd watch some news whilst Josh kicks around and tries to distract me. The news wouldn't be particularly interesting. I wouldn't get to anything I wanted before I eventually give in and would put on some cartoons, which he'd object to, before eventually I decide it's time to get ready for work. Get ready for work, hop in the car. I find there's a traffic jam. I sit there frustrated. I get to work 20 minutes late, still exhausted, and that's how my day would begin. We roll forward a little bit, and now my day still starts at 5:45. But the difference is now I turn around to Alexa and I ask Alexa, what's the time? There's no more fumbling in the dark. Alexa turns around and tells me it's 5:45. It's still the middle of the night for any sensible person. But at that point, I then turn around to Alexa and say, prepare my house for the morning. And all the light bulbs come on, and everything's all nicely set up. I walk downstairs. Nest knows that I now wake up in the middle of the night, so my house is set to a nice temperature. I get downstairs, we turn on the TV, Netflix is already open, it's already personalised what it is we're going to watch, so we just have Blaze followed by Disney Cars over and over, and Josh can sit and watch it. And it's really tiring because he only likes the first 3 to 4 minutes of it, but that's fine. And I can sit down, I open up my app, I have a personalised news feed, it tells me exactly what it is that I want to know about, so I can flick through, and I don't have to spend a lot of time reading a load of stuff that I'm not interested in. I get ready for work, I hop in my car, my phone connects to my Bluetooth, and Apple Maps tells me, well, you must be going to work. It's that time of day, it's learnt where I'm going, there's a traffic jam, let's take you around the country roads to get to work instead. I arrive at work, I'm now 15 minutes early rather than 20 minutes late. I'm still exhausted, as you can see, I still look like this, but I'm now on time and I've had a much easier, smoother morning. And a lot of that, although we don't perceive that we're dealing with artificial intelligence a lot of the time, every day, all of these different steps, we already have AI in our lives and we're using it in a whole bunch of products, whether we know that we're doing it or not. And all the major players, all the major companies out there are using AI. So some of them we know, some of them recommendation engines, for instance. We know that Spotify's only ever going to play me Britpop 90s music, and we've got a pretty good idea why that is. It's working out the profile, but some of the other ones are doing cooler stuff. So Tesla cars in the top corner, for instance. As you drive along and you start to slow down your car, it's a long straight road, there's no perceivable reason why, but Tesla realizes that everybody's slowing down their cars, and bit by bit it figures out that there's some kind of danger down there. So if you're driving down there with autopilot, then Tesla will figure that out and it will slow down because it knows there might be something wrong. And then there's the computer vision side of things. Obviously Tesla cars are constantly looking around at what's in the environment around you. And by using machine learning and artificial intelligence, they've taken down what used to be an error rate. So they sense about 30 times every second they sense their environment, and there used to be about 1 error every second, so 1 in 30. And now through things like AI and machine learning, that's about 1 in 30 million. And that's all courtesy of machine learning and artificial intelligence. And then kind of outside of these mainstream ones that are in the products we all use, we also have artificial intelligence being trained to do all kinds of other cool stuff, like writing operas, creating works of fiction. We do things like detecting bank fraud. We keep our network secure at work by using AI and machine learning. We're able to kind of do our cash management, so it keeps us in check from that side of things. There's a whole lot of stuff going on that maybe we're not aware of as well. And part of the reason that AI is becoming so powerful, part of it is consumer expectations. So we expect things to be more intelligent. We're not kind of happy just to be served up Commando because we watched an Arnold Schwarzenegger movie and it was Terminator, so we're just going to get another one. We want a little bit more insight, so we're a bit more demanding. But also, there is so much more data in the world today compared to what there was just a short while ago. And there's an unfathomable amount of data. There's no way that a human could take it in. So back in the days when we had mainframe computers, there was a relatively small amount of data. Then we started to move towards the web, and there was a little bit more, but it was quite a technical task still to publish on the web. Then we get to Web 2.0, and there's blogging, and there's social media, and there's selfies and dog skateboarding and everything else, and the levels of data really start to ramp up and up and up and up. And then when we start to look at IoT and smart sensors, connected devices, it goes through the roof, and there's just enormous amounts of data, and making any kind of pattern, understanding anything that's going on there, is a task that no human could do in a sensible time. Even by writing the smartest algorithms, we wouldn't get there. So that kind of leads on a little bit to the question of what is AI and why is it useful. I think a lot of the world, when we hear AI, think about these fantastic robots, kind of sentient beings. So we've got Terminator from Arnold Schwarzenegger, obviously a big fan. We've got Sonny from iRobot. For the 80s, we've got HAL, that type of thing from A Space Odyssey. And that's quite a long way away from where we are really with AI today. When we talk about AI today, we really talk about machine learning. And machine learning is what it sounds like. It's machines learning how to do tasks. And the building blocks for this have been around since the 50s, really. We've advanced them incrementally, bit by bit, but it's not massively new. And as I say, it's been around since the 50s. The big change came around the 90s. And that was when we started to learn about deep learning and neural networks. And the principle of this is slightly different. So rather than having to train the computer how to do something, we basically give it a whole host of data, the inputs, the outputs, and it figures everything out in the middle for itself. And this concept of machine learning, as simple as it sounds, is what everything is built upon. So when you talk to Siri and you ask it to send a text message to your friend, and it does something entirely different, that is AI trying to get smarter, relying on machine learning, and every time you do it, it's going to get a bit better and a bit better. When we look at computer vision, if you do something like the Tesla, or if you do something like use Google Translate to hold it up to a sign, all of that is coming through computer vision, and that relies on machine learning. So this is really the building block that sits underneath everything that we do today. So how does any kind of AI, or really how does a machine learning algorithm work? And the starting point for any of this is training data. So you tell it what it is that you're going to put in. You get a large sample size, and you give it all of the inputs, and then you give it all of the outputs. and then you set it off, and the machine works, the computer goes away, and it can take hours and hours and hours, or it does take hours and hours and hours, and it builds a neural network with a model inside it, which is incredibly complicated a lot of the time, and there are issues around the fact that we don't often know what's going on inside it. But from that point, it will then enable us to ask it a question, and using the data then the way it's trained itself, it will then give us the answer and the output from that. And probably this is one of the biggest challenges, is data-wise getting a good, strong, clean sample. Because if we give it too small a sample, it can learn and it will advance itself. But for instance, if we gave it a sample today and we said, right, where does everyone live? Everyone probably lives around the Surrey area. What's everyone interested in? Presumably digital. If we then took that, trained a neural network, and then asked the question, where do people interested in digital live? It would tell us Surrey, because this is the entire sample size that we have. So we have to have a sufficient amount of data for it to be able to draw good conclusions out of it. And then off the back of that, the next most important thing is it's got to be clean data. The world today is full of enormous amounts of bias, whether we're willing to admit it or not. And there are some really good examples of how these things can go wrong, because we're relying on these things to give us advice and make decisions for us. But if, for instance, there was an insurance company that was looking to build models out by using AI, and as it started to profile people, as it used the case history, an interesting thing came along, which was basically, because the data being created by humans was in itself slightly racist, as they then built that into an AI, the AI itself started to take on those traits. So if you then gave it the details of somebody from a certain origin and asked what it is that their policy should be, you'd find the premiums were much, much higher, and that was all just based on the human bias of the information that was put in the first place. And this raises a lot of ethical issues down the line, because increasingly we'll rely on these things for automation and to make decisions for us, and ensuring that they're not taking the biases that we're trying to move away from is quite an issue. So we can use these things. Once we train them up, we can do some really cool stuff with them. Like I say, you can deploy machine learning networks on your internal networks, and they'll see when network traffic changes. They'll find that suddenly you're contacting people in China from your printer an awful lot more than you were, and they'll start to close that down, because it's pretty unlikely that's something you were aiming for. But also we can do some other really cool things, like turn horses into zebras, and zebras into horses, and obviously apples to oranges as well. This is actually part of a project from the University of California, from Berkeley University. And as well as doing these types of things, it can do some other really cool stuff. So it can take, by training the network, it can take images of photos, and it can convert them into Monet paintings, and it can do similar things for Van Gogh and all kinds of other things. So although it seems like it's really simple, by learning the differences between two patterns, it can give you some really cool results. Obviously, there is a slight edge that even machine learning at the moment where we are, it always comes up with the odd error. Well, I kind of quite like the morph suit look, so I think that kind of works quite well. So these, obviously, we've talked a few like really data-y examples, and obviously we've shown pictures of zebras changing to horses. But the same kind of principles of giving it the input, the output, a couple of different ways you can train them, but that same principle can be used for all kinds of different things. It doesn't just have to be database things. So we can start to do things like look at some simulations and look at the robotics uses as well. Let me try. I love that video. I particularly like to think that we would have all learned to walk that way had we had the opportunity. So obviously there's some cool things around that, and then as we take these models into the real world as well. Got another short video to show. We quite often take for granted what we can do as humans. Our dexterity and our ability to interact with the world around us is much more advanced than maybe we think about when we go to just pick up a cup or something like that. But these challenges for robots in the real world are incredibly hard. And that's another thing that through a bit of machine learning we're able to teach them to work through that too.
Fine-tuning its weights to be as consistent as possible with the examples it's seeing. In this case, Apple is a computer, but when you're done having that talk out, when you're doing it and a grasp, it'll pop up and say, that's reliable, or that's not reliable. Inside a robot brain, this superpower is wonders. Using a 3D sensor, the robot will evolve these objects. If it's confident it has a good grip on its out, you'll succeed in execution 99 times out of 100. If a robot takes that at a 99% success rate, it doesn't actually even know anything about what the object is. It just says it's a pressure point 6 bits. Here's where I would grasp that pressure points. So it doesn't matter if it's a crumpled up ball of tissue or almost anything. That's a big deal because robots aren't great at manipulation of that. They're fairly mature, but they struggle to grasp things that you and I just have no problem. So if the world wants truly useful robots, it can't bother with teaching them how to deal with the problem linearly. Getting them to teach themselves is far more efficient.
Cool. So as you're kind of getting a bit of a feel for what we can do with machine learning is pretty varied. There's an awful lot of different use cases for it. And it's quite easy to get either overexcited by how it's going to revolutionize everything or equally terrified for how it's going to take over the world. So it's probably worth taking a little time to separate away what's the hype and what's the reality. Because the reality is that the artificial intelligence we talk about now is machine learning. It's systems that are very good at achieving a single task. So for instance, IBM Watson, which is one of the most famous kind of platforms, is tremendously good at things like image recognition. So one of the things it can do very well is image recognition. But if you then try and use that same neural network to do something different, like sentiment analysis or recognize a pattern in a bank network, it's completely impossible. They just don't do the same thing. So the networks that we train at the moment are really good at doing singular specific things. And when you look at something like Watson that offers you 15 different things, that's actually 15 different functions altogether. It's not one artificial intelligence. That idea of something that can do everything everywhere, that's not a thing right now, and it's not going to be a thing for quite some time, really. So what that comes down to then is what it is that we're going to use and what it is we're going to do with these facilities right now. And outside of the world of R&D and robotics, what we're really using it for is to access data in our businesses and help us power and make better decisions. It's kind of a natural step from a productivity point of view. We've gone from the world where, or since the web anyway, we've gone from the world where we had to get back to a computer to carry out a task, and then we started to take those tasks and we've moved them onto mobile, and everything's very task-orientated about completing things as quickly as we can. But you still had to go away and do a lot of the research and decisions yourself, and now we're going to use artificial intelligence to bring all that data together and give you a suggestion and take you to the end point. There are a lot of benefits to using AI and doing things in this way. Outside of the swiftness at which it can obviously achieve tasks, there's also a lot to be said for the fact that it's going to increase things like error reduction and increase consistency. There's another video here, bit of a shameless plug. So this is some work that we did using IBM Watson. And this is a project we've been running for a little while, and it's kind of like iStock Photo, but it's for textile designers. They have their own wonderful terminology for different things that you and I probably wouldn't use. I wouldn't know what a ditzy floral blurred blend would be, for instance, but this is the way that they describe all their fabrics. And at the moment, they've uploaded tens, hundreds of thousands of images to the platform, and the way that they deal with tagging these up so that people can search for them and find them is they have rooms of interns. Really sad looking interns who are going through image by image, tagging them for what it is that each one of them is. And of course, what one intern calls a ditzy floral blend is entirely different to what another intern might call it. So we trained a neural network that basically allowed you to upload it. We trained it with all the data that we had that had been checked and cleared for consistency. And we trained it to allow it so that now you can just upload an image and it will come straight back to you and it will tell you exactly what the different pattern types are in there. And then it just has a human there to confirm and say, yep, that's right, no, that's wrong. Every time you get something right or wrong, it learns, it becomes a little bit better. And very importantly, there are now rooms of interns who are smiling and doing constructive things that they wanted to do with their lives, such as doing the design and the creative work, rather than just ticking off the work for other people. So in an enterprise mobility talk that we do, we talk a little bit about the way that mobile phones coming into the workplace was kind of driven by us in our regular lives, by the kind of consumer, that we were going to start using our mobile phones to do things and we were going to bring them into the workplace. And it was completely up to the businesses to figure out what it is they were going to do with that, how they were going to make it productive, how they were going to control data and that type of thing. And a lot of what we're going to see as well, kind of coming across from the AI side of things, is our expectation levels are going to move in a similar way. Because we're going to be so used to seeing the big brands doing things in such a refined way where suggestions come to us, we're going to have to kind of replicate that out through businesses. So from a business modeling point of view, we're going to expect certain things to be done for us. From a decision-making point of view, we're going to expect things to be brought to us as well. We already kind of expect this personalised experience. And we have I quite often talk about an example when I went to a BMW showroom with the intention to buy a car. And I spent a lot of time doing my research at home, and I've been on the apps and I've been on the configurator, going back and forth, back and forth, back and forth. And the first 15-20 minutes that I spent in the showroom, I spent explaining everything I'd done previously to the salesperson. And they took a slightly different slant on it, and then they started talking about different things. And in the end, it all became a little bit ropey, and needless to say, I ended up not buying a car. Now, part of this is about connectivity of data, and one of the things that AI needs is data to flow, because obviously it has to get enough data to train itself. But under the assumption that we can achieve that, then the next step is to really focus in on actually making that experience so much better. And AIs today can do things like sentiment analysis, so they can look at your face to tell whether you're happy or sad and whether you're enjoying the experience. They can dictate what it is that you're thinking based on your tone of voice as you're speaking and that type of thing. So this means that as we go into the showroom, then already the AI is going to be able to look, and it's going to take the data, it's going to present that, and then it's going to take it and it's going to be able to tell whether or not I'm excited about what it is that's being sold or not. It'll be able to refine what it is, offer up advice to the salesperson, and then from there, potentially down the line, it can even start to give me advice on whether or not I should really be looking at the M4, because it's looking at my financial planning, it's giving me much better advice, and it's saying I should really go for a 1 Series or something like that. And any marketeer will tell you that the customer journey nowadays is much, much more complex. There are touch points all over the place. And as we kind of move through this journey, we're consistently inputting more and more effort ourselves. And we're creating more and more data through the different interactions that we have. And companies today are getting better and better at logging some of that. So we record information in CRMs, but a lot of the time it's siloed. So we'll have a chat program, Potentially the data isn't coming out of there and going anywhere else. And the little interactions, the data will get lost. So out of all of this data, about 5% of it is potentially usable at the moment. But it's quite easy to see that if you have an AI and you can actually start to interpret that data, you can start to do much more powerful things. So at the moment, we're quite used to things like remarketing. So you go to somebody's website, if you go to our website, and then you leave our website, and you'll go around the internet and you'll find that we'll follow you, and you'll see our adverts popping up everywhere. There's no escaping. And that's the kind of level that we're used to at the moment. But there's no reason why down the line, if you're using AI, why there can't be a connection through to things like Facebook to get a bit of a better idea of who you are. And then we can use AI to remodel the text on the pages altogether. So there are already examples of AIs being used by Saatchi & for instance, to tweak copy on text on websites to make it more appealing to the users. It's not that much of a further step to think that you can combine that with some of the publicly available information on Facebook, and you can have an entirely custom website that's aimed just at you. And then when we look at things like chatbots and customer services, then the way that we talk can be deduced. There are personality tests, for example, that you can do. James did one a little bit earlier today with some awful results for him. But they can tell a little bit more about you, which then means that things like support programs and chatbots can tailor the way they talk to the way you like to be talked to. And all of this is, of course, improving customer experience. And then as we take this out into the connected world, the physical world, the idea of these connected devices is quite interesting when, ironically, at the moment, they're completely unconnected a lot of the time. So my light bulbs don't talk to my thermostat doesn't talk to my music. It's a real problem. Can't sleep at night. They do their best, but they rely on things like your iPhone HomeKit or Alexa to sit in the middle and interpret and shift data back and forth. But down the road, there's no real reason why your light bulbs can't learn to talk to your thermostat, and all of that stuff then tunes your entire home life and then out into your work life and everything else. There are, as I mentioned at the start, you have to use a lot of computing power to train a neural network. But there are advances being made, and nowadays Google, for instance, their TensorFlow platform, once you've trained it, you can deploy it onto a mobile phone, which means you can do image recognition on your mobile phone without an internet connection. And similarly, Microsoft have now done a similar thing where on a £30 Raspberry Pi, you can deploy a trained neural network onto there. So smart devices around us can really become smart, rather than just sensors that rely on something else to be smart. They're going to be able to be smart themselves. Now, as I say, there are a lot of examples in the real world today where platforms are making our lives better and more pleasurable. Netflix is one of the ones we've talked about. Historically, obviously, as I say, they used to just look at genres and actors to choose what it was that they'd recommend to us. And nowadays, through the massive data they have, they can look at what we do in comparison to everyone else and produce recommendations. But their technology goes further than that, and they're using machine learning to anticipate scenes and different parts of programs where you're going to need more and less bandwidth, and where the image quality matters more and less. And that means that they can then change the signal as it comes down, which means that you need less bandwidth, which means less buffering, which means a better experience. Wimbledon, very recent example, a very cool example as well. So Wimbledon paired up with IBM, and they were able to use Watson to do a lot of good stuff. So they did things like automatic creation of highlights from the day. So they're able to track ball movements, they could look at the players' faces, they could understand whether they're feeling, they could listen to crowd noise to get a feeling of how tense it was. They took into account things like how important the point was, if it was a break point. And from this, they were able to create highlight reels an awful lot quicker than they ever had before. Rather than waiting for humans to sit there and work through it for hours, it was pretty much on the fly. Then they did things like they did facial recognition. So if you were a massive Federer fan, for instance, you could be alerted when he went out to the practice courts. And you could sit there and you could watch Federer knocking up rather than missing it completely or focusing on something entirely different. The guys at Ocado, so not the robot, just illustration really, but Ocado customer services get flooded by emails, customer support emails. And as anybody that's ever worked in customer support is aware, there is a massive variation in how much importance some things have. So Ocado used TensorFlow by Google to categorize and rate on importance, how important an email actually is and how important that inquiry is. And then they can deal with the really important ones really quickly, and the other ones obviously they'll deal with slightly slower. They're also doing things like image recognition to try and do away with barcodes. So rather than having to barcode scan stuff as it comes in, you can just hold up a device, see the package, and it'll tell you exactly what it is. One of the other cool ones, I don't know if anybody's ever come across or have heard about Amazon Go. Amazon Go is Amazon's kind of checkoutless store. So you can walk in, you can find your stuff, and you can walk back out, and you never pay. Well, you do pay. You don't pay at a checkout. It automatically comes off your card, so in this completely seamless ecosystem. So they're using things like computer vision and all kinds of different sensors to try and figure out what's going on. And I have a fantastic Americanized video for you here as well.
4 years ago, we started to work. What would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We use computer vision, deep learning algorithms, and sensor fusion, much like you find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
So that's pretty cool. It's maybe a little bit hopeful. It's very much the future. It's very much not the now. So that particular shop is open only to Amazon employees, and you can only have about 20 in the store at any one time before everything goes a bit haywire. So we're not quite going to see it in Tesco's anytime yet, but you can see how the things are developing, and the rate at which things are developing is incredible. Stuff is out of date almost as it's discovered and as it's worked on. So there's the natural question of what it is that we should all be doing, because we've talked an awful lot about big businesses and how it's going to affect us all, but there is the question of what we should all be doing ourselves. And there are a lot of common themes alongside any other new technology that's come along. So the first one is, what's the business driver is about the most important. Every time there is a new kind of revolutionary piece of technology that comes along, people flood out and they start doing projects in it because they just want to be doing a project in it and they want to be able to say that they're doing something with AI, machine learning, whatever it is. But unless there's a good, strong business driver for it, ultimately there is no reason to do it. So the first thing is, understand what it is you want to do. If you want to improve customer service, if there's a part of the logistics or the supply chain you want to improve, then focus in on what it is you want to achieve. And the next part is around data. You've got to make sure that your data is in a good shape, that you have it. Now, businesses that are in the cloud already have a massive advantage here, because the cloud is naturally, or typically anyway, much more open to sharing data. If you've got old legacy systems, then that's going to be a little bit trickier, so you need to look at what you can do to get that data out. And then equally, it's got to be clean, so you've got to look at how useful and how relevant it actually is. The next one about training your team, there is almost always a question about what's going to happen when the robots steal our jobs. And the reality is that they're not going to steal our jobs, at least not in the near future, but they are going to change a lot of jobs. So it may well be that robots or other AIs, machine learning, is going to be making suggestions. It's going to change how customer support people do things. It's going to change how people in the warehouse do things. And therefore, people are going to need training. They're going to need to understand why we're doing it, what we're doing it for, how we're doing it, and how it's going to affect them. And then potentially they're going to need some different training to what they were doing before. And finally, research and planning and being agile, all in kind of one together. You need to keep an eye on what it is that's going on. Like I say, the field is changing so rapidly. Keep an eye on your competitors, what they're up to, because what it is that people are doing today, in 3-4 months' time, it'll be entirely different and it'll keep moving. So you can put your toe in the water and try a few different things, but really keep an eye on the developments and understand what it is that's possible and what it is that's out there. And there's kind of quite a good incentive. This is from Forrester's. So they reckon that, and you can kind of liken this a lot to digital. So when digital came around, obviously businesses that embraced it did tremendously well. Those that didn't were maybe left behind a little bit. AI is going to be pretty similar. So according to Forrester's, by 2020, which really isn't that very far away, there's about $1.2 trillion of revenue to steal for businesses that are going to do or use insights from AI properly, and are going to use it to improve their offering. So there's a reasonable cause for looking into it a little bit more. And that's about it. So that's about all I've got to talk about today. Thank you very much for listening. If you've got any questions at all, then feel free to shout, or indeed if you've got anything specific you want to talk about, then feel free to grab me outside. Cheers, guys. Yes.
Just curious, in terms of the data input, just look at unbiased data as an example, how easy is it to correct unbiased data or inaccurate data once it's fed in?
Once it's fed in, because the neural networks themselves are so very complex, like for humans to understand, they're incredibly complex. So actually backing out of it and retraining it with something different is pretty hard. It's not a case of highlighting that row and deleting it. It's really hard to bring it back in line. So you've really got to be careful and make sure that as you go into it, you've got the right data going in.
So you have to be a definition of clean data.
Yeah, you want to start from a good place. Yeah, sure.
Yeah, hi, thanks. Great talk.
Thank you.
So if you're, say, with the 50-man SME like I am, where would you recommend I sort of read a little bit online about what I should be looking at in terms of technology for the business to introduce some of this?
Where to read?
Yeah, what sort of material to research to try and get some AI into the business?
Well, I think, so the key thing is really focusing on what it is that you guys want to improve, as much of a non-answer as that probably is to you. But, I mean, obviously the more data you have, then the more accurate the model you're going to get. But there's a good example of, I forget the company's name. They had a sales team of about 50 to 100 people. And they had some guys that were doing really well at answering chat programs. So they had a much higher sales rate than the other guys. No one knew why. And that's not a tremendous amount of data. But through using AI, they were able to plug it in, and then they were able to get suggestions in real time as to what people should do. And they saw a tremendous increase. It's a 150% increase in sales just by using the AI to suggest what people might do. So although more data means typically more accurate networks.
Is AI is custom written, or is it, do we go to someone like yourself, or is it like, you know?
Is there a box?
Microsoft AI, or
Yeah.
where am I looking? Where should I look?
Yeah, I mean, so a lot of the time, typically you're using other people's platforms. So you're using Watson, Microsoft have one, Google have one, Amazon have one, and as you can imagine, they're all flocking. So you use a platform, but you might look to somebody else to integrate it and build it, because they're kind of data driven. So to put your custom integration on the top, you'd go to an agency, yeah.
Yeah, got a question coming from Twitter Periscope. Any thoughts on how to increase sales for small, medium businesses using AI?
Yeah, well, I mean, a good example is the chat one a second ago from a conversions point of view. Looking at where it is that you're trying to increase sales from. If you're trying to generate more leads versus actually close them, then having the data going in, understanding what it is that's failing is a really good place. And that chat example is fantastic because seemingly there was no reason why people were doing differently. But just by making a few suggestions, then you can increase the close rate hugely. Sure.
Yeah, hi. A lot of things that you're looking at seem to be to do with commerce, maximising sales, customer relationships, that sort of thing. I mean, presumably there's other applications. I mean, and how accessible, how much work is there in well-being, in climate change mitigation, in conflict resolution?
Yeah.
I mean, you know, you hope, or someone like me hopes that these techniques are going to be used to solve difficult problems rather than sell more stuff to people.
Yes. Yeah.
Fair?
Yeah, it is. Yeah. I mean, it's machine learning, so you're teaching a machine how to do something better. I mean, obviously, the examples I've given there are kind of focused around that, but we also talked about things like securing networks and that type of thing. And this is all about spotting changes. So you can absolutely, I mean, people use them to simulate all kinds of different things. National grid peaks and troughs of energy. They use them to simulate awful things like wars and the like and everything else, but you can use them for a whole host of different things. It's just about the application of them. And one of the main things at the moment really is about people understanding what's possible, but equally having enough imagination to do something different with it. Is that area where, as it comes to people's attention more, there's almost more awareness needed to understand what it is we can do with it. Sure.
To continue that theme, I'm here from Surrey Police. So what malicious?
Okay, and thank you very much, and good night.
What malicious uses do you see for AI, and how might we mitigate against that?
God. Oh, thank goodness I asked you. Yeah, I mean, well, the biggest risk. So there's loads of arguments going on at the moment. If you read online, then you'll see Mark Zuckerberg and Elon Musk. Yeah, they're consistently having a go at each other over whether it's a fantastic opportunity or the end of mankind. Hopefully, the answer is somewhere on the Zuckerberg side, which is a fantastic opportunity. But I think that some of the biggest risks are relying on what it is that they're outputting and therefore training one badly. Because it's quite easy. We might ask it to give us suggestions or answers, but we might also use them in automation. And as we use them in automation, if there's the ability to manipulate one by giving it bad data, then you get bad answers. And I think that's a lot of what the Musk-esque fear is, that we'll give it access to the big red button, and then somewhere on the line the wrong data will get in and off we go.
Yeah, or even we've talked about, so you get a terrorist group that cooks up its own sort of homebrew AI, as it were, puts it in a vehicle and sticks the vehicle to hit the crowd rather than the crowd.
Autonomous vehicles. Yeah. I mean, there are obviously opportunities for that type of thing. I mean, I think I'm not going to venture any kind of opinion on what they may or may not do. But a lot of those risks of the output are probably reasonably similar to the things that they may well carry out today anyway. Yeah, at the back, yeah.
What professions, day-to-day occupations, would you say are most under threat of AI? Think about truck drivers in America.
Yeah.
The cashiers in the shop.
Sorry?
The cashiers in the shop.
Yeah, well, the guys at Amazon Go aren't doing so well. Yeah, I mean, everybody is always worried that any new technology is going to destroy all jobs, industrialization, computerization, all of these things. And in reality, a lot of the time it changes it. So there'll be some job losses, but then hopefully those will lead on to facilities where people can do things that they enjoy, and maybe where they use human capabilities and the things we're good at a lot better. AIs are good at carrying out these algorithms. They're not great at judgment. That's not a thing where their strength comes in. That kind of comes back to us still. So what we do will change, but then I don't think too many people are particularly sad that they're not sweating in a factory for 14 hours a day either. So it'll definitely change, and that's why the bit about communicating with staff about what's going on around them is so important, to belay the fears and just make people understand that things are changing, but it'll be for the better. Yeah.
One of the issues you identified was the importance of training people in the skills to work more effectively with AI.
Yeah.
What do you think is going to be different in terms of skills? What are the priority areas?
Yeah, there's an interesting piece that I was reading the other day, and it was talking about exactly this. It was saying how it's almost, because of the role that AI is filling, it almost changes our skill sets to be slightly more leadership focused around decision making, understanding, and then implementing those. So that will probably be the biggest difference, is that people will be almost using their minds more. That sounds awful, but they'll be making those decisive decisions and then following through on it, I think, is probably the biggest change.
Yeah, it's interesting. I mean, after 20 years of spreadsheets, most people still don't know what spreadsheets are. So I'm kind of wondering how we then make that leap to suddenly knowing what's the right question to ask, interpreting whether the data makes sense, but we don't actually know how it's making the decision. It's going to be interesting.
And it is. I mean, there's interesting, like the human mind, most of what we know, we don't know how we know it or how to do it. If you ever try and explain why you're doing things in a certain way, you'll just kind of scratch your head and get lost. One of the weirdest things is that machine learning and artificial intelligence, where we are, we've almost created that straight away. We don't know what's going on inside the networks, but we know what's going in and coming out. It's not that dissimilar. But yeah, I'm with you.
Sorry, which companies do you think are currently using machine learning and AI very effectively?
Very effectively?
Are there any standout examples of, these guys are doing really well? Have a look at it.
Well, on a large scale, Google are pretty good. Everything from maps to search to news, everything. They've reworked pretty much everything to run through machine learning. Amazon with recommendation engines, that type of thing. You'll start to see it everywhere. Like I say, you might not know it, but it will run through your CRM systems. It will run all over the place. There's a lot of money being pumped into AI at the moment, just floods of it in startups all over the place. And then in a few years to come, you'll probably hear about it an awful lot less, because there'll just be an assumption that it's in there. Like nobody gets excited about the fact you've got a database system at the back of anything. Like, it's just there. And machine learning will be pretty similar. You'll only notice it because the service will be a lot worse if it's not there, but you'll assume that it is.
Yeah, I was just wondering, with all this data that you're feeding into machine learning mechanisms to train it, and presumably the data that it's gathering by itself as well, where's that all stand as far as data protection goes? Not to be forgotten, because it's fairly simple-ish if someone's just saving a load of information on a CRM system or a server, when it's disappearing into this neural network, and you can't actually quantify what that is, because it might not actually be a safe piece of data. It might be that it recognises a voice, say, or a face through a bunch of algorithms. How do you kind of deal with that?
I mean, the network itself, obviously, it's trained, but it doesn't retain that data. So what it learns, it then uses next time, but you couldn't, for instance, ever get out what it's been used to train it. When you come to look at the kind of connectivity and bringing all that data together, and the fact that all those systems want to talk to get the most out of it, then that's a hell of an issue. The data protection and what it is that you can get out of it as well. So what you can learn about an individual through sentiment analysis and everything else is a massive thing. And it's probably one of the biggest things that's going to hold things back is legislation and privacy issues around it. I think there are a lot of people scratching their heads on it. As in training the machine learning? Yeah. No, there's no. It's a turn of phrase. It's basically the supply of the data, and then what's going to come out of it. So it's kind of like setup as much as it is training, really. Yeah.
How much data do you need in order to start making some meaningful patterns? Because in a small business you may not have millions of data points. Is there a kind of rule of thumb that says don't worry unless you can get 10 million data points?
I think more is better. Obviously, you get better results, more accurate results. But the example that I used of the chat systems is a really small amount of data. You're going to get very different results, but you're looking for an improvement at that point. You're not looking to change the world. As with everything, what Google are looking to achieve is going to be different to what we're looking to achieve. And therefore, progression doesn't necessarily mean you need 1 million data points. It just means you need enough to get going, and that's down to what it is you're trying to do. Cool. Lovely. Great stuff. Thank you very much. If anybody has any specific questions, technically, as I say, I'm going to aim you at James, but anything else, then just grab us outside. Thanks, guys.